All right, good afternoon, folks. I'm Ed Armstrong. I'm from the NASA Jet Propulsion Laboratory in beautiful southern Smoky, California. And I'm going to talk to you about a visualization tool, an oceanographic visualization tool that we built here. I'm not the lead architect of this. There were a lot of clever software engineers, data engineers, and scientists who were behind this, but I'm going to present the functionality of the tool and hopefully pique your interest of using satellite data to observe various features in the oceans. Okay, so state of the ocean, it stands that SOTO is a web client for multi-layer visualization. For looking at various data layers, including temperature, wind, sea level, salinity, currents, biology, and a few others as well, as you'll see. So what else besides just simple visualization can SOTO be used for? Well, there's a capability of course, doing image overlay and toggling between the various different layers to look at kind of like correlated properties, and I'll show you an example of that, as well as simply just animating a time series of the images. And we can do some minor color manipulation of the color maps that are embedded in the images. And as well as we can do some cursory data interrogation of the data values, of the pixel values. And these images we're leveraging images, we're both creating and using images from the NASA Global Imagery Browse System, GIBS. So we actually pull images from them as well as we create some of our own images internally for this tool. So here's a snapshot, a screen grab of the tool, and we're looking at an image of sea surface temperature. This is the level 4 1 kilometer Muir data set. Down on the left hand, you see the calendar there, and there's like a little slider on the bottom where you can kind of toggle between the different days. And so we get the synoptic global features of sea surface temperature from this particular image set. And of course, there's other layers that embedded that you can extract. And here's an example of the different physical parameters again that we're supporting, all the way from ocean color to soil moisture, surface precipitation, and true color. So there's some non-ocean stuff in there as well. But it's mostly about the height, the salinity, the temperature, the biology, and the ocean wind. And you can click on the various different layers and then get some more information from the metadata record and actually get endpoints where you can actually go off and get the data that you're visualizing. So here's a little example of the overlay functionality. In this case, we have two images loaded up, that Muir Absolute SST, and we also have an Anomaly SST product up, and we're kind of toggling this little opacity here. And so the anomaly is set at 30%, the temperature is 100%, and you can see here kind of like the peaking out, the cool, in this case, these tropical instability waves. The blue tones mean cooler than usual, so you can kind of see that play between the absolute temperature and the anomalous SST in this case. So I'm going to move off now and actually do a live interactive demo of some of the functionality of this tool. And so I have two use cases loaded up, but I'm actually going to use the one for the Gulf of Tehuantepec because it's a very interesting oceanographic. And actually that URL that I just hit doesn't load up because Microsoft kind of truncates it, but I cut and pasted the big URL. And here's what we're looking at here. This is the Gulf of Tehuantepec in Mexico. We see the Gulf of Mexico in the northern top of the image, and of course the Pacific Ocean in the south there. And very frequently there's these winds that slide through this gap right here, this kind of large lowland valley here. And as they come out on the other side, they're actually accelerating. And you can see these wind vectors. Now these are wind vectors from the the ASCAT instrument. It's a scatterometer, a European scatterometer flying in space. And what we've plotted over here are the wind vectors on top of the anomalous SST. And this feature, of course, these winds are accelerating here, and there's like a surface divergence going on here due to the curl of the wind field, pushing the water to the right and the left, and up beneath it comes the upwelled cooled water, and that's what we're looking at. So this was kind of a recent event. Actually, this was November 15th, about a month or so ago, and you can kind of like move around in the time series and see how it waxes and wanes. So around the 12th, it was a little bit smaller and then kind of grew in size as the wind kind of picked up here. You can see these winds here. This is a very long wind barb indicating a very large speed. You can actually go over here to the color map here and kind of toggle around and see, okay, well, that's about 20 meters per second is about 40 knots. I mean, that's a very strong wind, and so that's what's causing this oceanographic phenomena. All right, so I think I've shown you a little bit. Of course, we can look at some other layers. Let's look at the ocean biology. Now we're turning on the surface chlorophyll from the MODIS instrument. And of course, these cool upweld signatures are often correlated with phytoplankton blooms, and that's the case right here, where there's a little phytoplankton bloom that took off and kind of waxes and wanes as well. So I think I'll just kind of stop right there and maybe just show you like one other additional layer. There's some non-ocean stuff in here as well, including the true color imagery from the MODIS Aqua sensor. And if we just step up to the last few days, maybe we'll go back to yesterday, and we'll kind of zoom out and just observe the fire signature here in Southern California. So this is this large fire that's now encroaching on Santa Barbara. And just to say a few words about that, I have a friend who's a fire captain up in the Santa Barbara there, and those men and women are really out on the front lines right now fighting this fire. So just, wish them all the best. They're trying to save tens of billions of dollars worth of infrastructure right now, and this is a really serious situation. So they're out there earning their pay. Of course, we're at this conference earning our pay too, but later this afternoon we'll be doing that over a beer. So wish them all the best. I hope that this tool is going to be interesting for you, and go ahead and play around with it. It's primarily tuned for the oceans, but of course there's other features that you can observe in it. So thank you very much.